this session, I want us to go through the process of sketching exponential functions. So we are sketching the functions of this form. Y is equal to a times b to the power of x plus q. Okay, so these are the functions that we are sketching. And in in one of our sessions, we spoke about the different shapes according to the different values of A and B. Okay, so let me just quickly remind ourselves what we spoke about. So we said that if A is positive and B is greater than 1, then our graph has this shape. A graph has a shape like this. It curves upwards like this. And then we said that if A is less than 0, but then B is greater than 1, then what will happen is this graph will be reflected over the asymptotes. So this graph will look something of the sort. So we will have a graph that curves downwards. Okay, so it will be like this. So it will be something like that. Okay, so it will be like that. And then we said that if we have a a being negative and then b being a proper fraction between 0 and 1, then this means that we will have a situation of this sort. Okay, our graph will curve upwards, but then it will curve upwards in this manner. Okay, um, our graph will curve upwards like that. Okay, and then if we have a situation whereby a is greater than 0, but then b is a proper fraction, or b is between 0 and 1, then our graph will look something of this sort. Okay, our graph will curve downwards, but then it will curve downwards in this manner. Okay, so these are very fundamental concepts that we need to be familiar with so that we can be able to sketch our functions appropriately. So these are the sketches that we will use as a guide, such that or so that we are able to sketch this graph and that graph. Okay, so I'll just leave them here so that they will serve as a guide. Okay, so I'll just take this. Okay, so to sketch these functions, we need to understand these shapes. Okay, so basically what we will do is we will analyze the values of A and B in this graph that we are required to sketch, and then we will see if it belongs to category 1, which is this one, or this one, or that one, or that one. Okay, and then we can be able to assign it a proper shape. Okay, and then after we have understood that, we need to determine the intercept. Okay, so we will determine the x-intercept. If there is one, we'll determine the y-intercept and see if there is one. And then very importantly, we will determine the asymptote as well. There's nothing to determine, so to speak, because the asymptote is always y is equal to q, and the q value is equal to 2. So we'll just read off the asymptote. Okay, so let's get started. Okay, so we can see that the asymptotes, we can just start with the asymptote. The asymptote is given by y is equal to q, which is y is equal to 2 in this our situation. And then let's determine the intercept now. So the intercept, so let's get the x-intercept. If we do that, we must let y equal to 0. Okay, now if y is equal to 0, what will happen? 2 to the power of x, 2 to the power of x is plus 2. So 2 will go to the other side. So negative 2 is 3, 2 to the power of x. And then we can divide by 3 on both sides. We have negative 2 over 3 is equal to, so negative 2 over 3 is equal to 2 to the power of x. Now, this is not possible, okay? Because if we think about this, what we have on the right hand side, we think of any value of x that you can substitute in this situation. If you substitute 0, you will get positive 1. If you substitute a positive value, this will be a positive 1. Even if you substitute x is equal to a negative value, what will happen? This will still be a positive fraction. Okay, so 2 to the power of x is always greater than 0. Okay, it will always be greater than 0. So this situation that says that 2 to the power of x is equal to negative 2 over 3 is never going to happen. Okay, now this is a good indication, or this is a clear indication that we do not have an x-intercept. Okay, so there is no x-intercept. So there is no x-intercept. Okay. And then let's determine the y-intercept. The y-intercept, we'll get this by letting x to be equal to 0. Okay, so we let x be equal to 0. Now, we know that the equation is y is equal to 3 times 2 to the power of x plus 2. If x is equal to 0, then okay, so if we have x being equal to 0, now 2 to the power of 0 will just be 1. Okay, so we'll end up with 1, and then 3 times 1 is 3, 3 plus 2, this will give us a value of 5. Okay, so the y-intercept of our graph will be at x is equal to 0 and y is equal to 5. Okay, so we have the y-intercept, we have the equation of the asymptote. Now let's figure out the shape of our graph. Okay, so we know that these graphs are given by this form: y is equal to a times b to the power of x plus q. Okay, so we can see that a is positive, so a is positive 3, and b is equal to 2, so b is greater than 1. Okay, so we are looking for a situation whereby a is positive and b is greater than 1, and we can clearly see that this is this first scenario. Okay, so we are expecting our graph to look something like this diagram. Okay, so we can we can come up with a sketch, and we just sketch it here on the side. Okay, so we can see that it will be like that. and then the asymptote is y is equal to 2. Okay, so we have our asymptote at y is equal to 1, 2. So this will be the line y is equal to q. So y is equal to 2. This is our asymptote. And then um, we have our y-intercept at x is equal to 0, y is equal to 5. So this is this is 2, 3, 4, 5. So we have a y-intercept there. Okay, and then let me just extend my axes. Okay, so we we saw that our graph will look something like the first diagram, that one. Okay, so it will be something like this. So it will pass to this point, and then it will be something like this. Okay, so this will be our first graph. Okay, so this is the y-axis, and then this is the x-axis. Okay, and then let's now deal with the second example. Okay, so let's deal with the second example. Now, in the second example, they say that y is equal to negative 2 into 1/3 to the power of x minus 1. So, as always, we start with our asymptote. So, we say asymptote, the asymptotes are or is given by y is equal to q, and in this case, we have q being equal to minus 1. Okay, and then we can now determine the intercept. Okay, the intercept. Now let's start with the x-intercept and see whether we have an x-intercept or not. So the x-intercept, to do this, we have to let y equal to 0. So let's do that. We will have 0 is equal to negative 2, 1 over 3 to the power of x minus 1. Okay, and then we'll take the 1 to the other side. It will become positive 1, negative 2, 1 over 3 to the power of x. Okay, and then if we divide by negative 2 on both sides, we see that we end up with negative 1 over 2, which is equal to 1/3. Okay, 1/3 to the power of x. And now, even in this example, we end up with an ambiguous situation because this is not possible. Okay, so 1/3 to the power of x can never be a negative number. So we we note that they are no x-intercepts. Okay, so there are no x-intercepts because of this situation. Now let's consider the y-intercept. The y-intercept will determine the y-intercept by letting x to be equal to 0. Okay, so if we make that happen, then we can determine the y-intercept. So y is equal to negative 2, 1 over 3 to the power of x minus 1. Okay, so if we plug in x is equal to 0, then it will be something of this sort. It will be negative 2 multiplied by 1 minus 1. Now, negative 2 minus 1 is minus 3. Okay, so this gives us a value of negative 3. And we can conclude that the coordinates of the y-intercept is x is equal to 0 and y is equal to minus 3. Okay, so we have the y-intercept, we have the asymptotes. Now let's figure out the shape of our graph. Okay, so we can we know that these graphs are given by y is equal to a times b to the power of x plus q. Okay, so this is our a, this is our b. Now our a is negative in this situation, so our a is negative, and then our b is between 0 and 1, like that. Okay, so we from these four diagrams that we constructed earlier, we are looking for a scenario whereby a is negative and b is between 0 and 1. Okay, so this, no, not this one. um, A is negative. Okay, so this is the scenario that we are looking for. This one. Okay, so this is how a graph will look like. Okay, so let's draw it to it over here. Now let me just place the that sky over there. Okay, so this is the situation that we have. So therefore, we are expecting our graph to look something like this. Okay, so let's sketch the graph that we have. Okay, so will be like that, and then it will be like that as well. So this is the y, this is the x. Okay, so this is the x-axis, this is the y-axis, and then we can insert the asymptotes. The asymptote is y is equal to what? Y is equal to minus 1, I mean. So the asymptote will be y is equal to minus 1, just over here. So y is equal to minus 1, like that. And then um, we have determined the y-intercept to be at y is equal to minus 3. Okay, so we have a point here. So we have, this is minus 1, minus 2, so minus 3 will be somewhere over there. Okay, now we we note that we can just extend this a little bit. Okay, so we know that what will happen is we'll have our graph looking like that. So it will be like that, something of that sort. Okay, so this is how our graph will look. Okay, and then we can put the coordinates of this point, which is 0 and minus 3. Okay, so hopefully you can see that having the understanding of the four sketches, these sketches, they form the basis of sketching exponential functions. Okay, so make it a point that you are comfortable with these relationships, the relationship between A and B, because they are the